So my presentation about my topic about neural-based segmentation of flotation Froth images to improve the quality of segmentation. In this speech, I will not present any formulas, any numbers, just short brief about our research. Let's start from relevance. According to PricewaterhouseCoopers analytics, transport and storage economic sector stands out as a sector with a particularly high potential for automation in the longer run. In particular, two occupation categories, medium long run automation rate of up to around 64% for machine operators and assemblers. Also, they divided the automation into three stages: algorithm wave, focused on the automation of simple computational tasks and analysis of structured data in areas like finance, information, and communication. This is already well underway. Second wave is the augmentation wave, focused on automation of repeatable tasks such as filing in forms, communicating and exchanging information through dynamic technology support, and statistical analysis of unstructured data in semi-controlled environments, such as aerial drones on robots in a warehouse. This is also underway, but it's likely to come to full maturity in the 2020s. And the third wave is autonomy wave, focused on automation of physical labor and manual dexterity and problem solving in dynamic real-world situations that require responsible actions, such as in manufacturing and transport. Example, driverless vehicles. These technologies are under development already, but may only come to full maturity on economy-wide scale in the 2030s. With the latest advances in deep learning, automation is taken it to the next level. Current industrial automation methods are being replaced by deep learning-based methods, and most of them are at the stage of pilot tests. Thus, currently there is a high demand in the industry for deep learning-based automation methods because the conventional methods are inaccurate, but deep learning methods have big disadvantages in the form of a lack of data, and in the second disadvantage is binding to the specific domain. Now, in this report, we'll present the current state of flotation analysis, the problems in this area, and solution this in other areas, not only this areas, because Froth analysis is a very specific area. In short, Froth flotation is one of the methods of mineral processing where hydrophobic materials are selectively separating from hydrophobic. In this way, we can extract useful minerals from raw ore, and we may use the CV methods to analyze Froth surface and then control the operational state of flotation machine based on this analysis. Until recently, in the case of Froth surface analysis, conventional CV computer vision methods were used, like watershed algorithm, for example, to get a segment mask from the input image. After this, engineered feature were extracted and passed to some machine learning algorithm to make a prediction of target variables. Modern approaches used deep learning to avoid future abstraction and obtain target variables directly using classification to Froth grade or regression to working conditions. But these approaches requires a lot of label data and are non-universal, non-flexible. For example, I don't know, extracting from sync, extracting a sync from or may occur with different conditions than extracting cuprum or gold or silver. Therefore, segmentation methods become more flexible. Many researchers reports about high correlation between metallurgical performances and Froth features like on the slide, like bubble morphological features like bubble size or bubble color, number of bubbles, lightness. Also, the Froth mobility, that means velocity of Froth, or Froth stability, that means frequency of the bubbles burst. Also, there are some researchers. This research based this researchers made extracting features based on elliptical structure of each bubble, based on conventional that each bubble is elliptical structure. To that, some researchers focused on segmentation of bubbles in Froth surface image and then extracting this feature from each bubble instance as previous researchers. To occur bubble instances with semantic segmentation methods, researchers trying to penalize networks at the boundaries of the bubbles to get non-breaking boundaries between them. And labeling data for such tasks is hard time consuming inaccurate work. Some classes of Froth may contain a lot of small bubbles, which are blurred due to camera restrictions. So many researchers labels only part of bubbles with a specific size threshold. The rest of Froth considered as the one big area with small bubbles. Such solution does not lead to good results. Also, it doesn't allow to correctly calculate such metrics like perception over unit on model testing. So now we have a bottleneck in the form of a lack of good labeled data. And some solution we are researching that can apply it to this problem. On slide, you can see part of the solution, like few-shot learning or semi-supervised learning, because we have an access to a lot of unlabeled data from video camera. Also, there are transfer learning, particularly three-dimensional modeling, and data augmentation indicates some of them, like basic data augmentation methods and elastic deformable transformation that is used often in medical data augmentation. And narrow-based new approach data augmentation for data augmentation. And many of this solution was widely considered in other larger domains like autonomous driving, microscopy, and medical image processing. Unlike our task, which is, as I said, is specialized. So we will consider some of the researchers from other domains. First of all, is transfer learning. So one of the solutions to deal with lack of data is transfer learning when the model is pre-trained in other domain. In case of this pipeline on the picture, we become dependent on architecture, and that was chosen on parent domain. Another problem are that the model becomes over-parameterized in case of transfer from a large domain to smaller domain. And another conclusion made by some researchers is that transfer learning primarily helps the larger models compared to smaller ones. Apart from that, large models change less during fine-tuning, especially in the lowest layers. In the paper on the slide, was considered the transfer link from ImageNet to medical domain. They have made conclusions such as transfer the scale or range of weights instead of weight themselves to each layer of neural network, and use the pre-trained weights only from the lowest two layers. Also, and there is another one similar research that reports transfer learning from ImageNet to brain tumor segmentation, and this research showed very small increase of accuracy of the score, about 0.5% or 1%. This research. More interesting research. It's called this model called MET3D. They are trained a model on several datasets. For each dataset or modality, they have own decoder, but shared encoder. And then shared encoder then used as pre-trained model for a concrete task. In this paper was the task was segmentation classification, and as can you see, the accuracy increase about 10%. It's a very high increase. And interesting that they used encoder, shared encoder. It's in our domain with bubbles segmentation. Found a similar model called domain called with a model called CellPOS. That is a model for cell segmentation from IP. So in our task, we just try segment non-fine-tuned CellPOS model, and it can segment some bubbles, but the CellPOS model was trained on cells with identical size of cells. And in our task, it shows wrong results, trying to segment bubbles as identical size. Also, often this model segmenting only the highlight on the bubble instead of whole bubble. This model can be considered as a potential model for transfer learning to our domain. And about segmentation, about augmentation, this diagram on the slide show the number of users, the various types of augmentation techniques since 2016 to 2020. Research notes the interests in neural-based augmentation in the last years, but this paper was released in 2020s, and this study mentioned only after coders and GANs in neural-based augmentation, but recently there are new papers that used augmentation diffusion models. For example, in neural-based augmentation, they're often used style transfer for augment the trained data, because style transfer is saving the context of the original image. So some researchers this is simply segmentation technique in neural-based, and where image-to-image translation model is placed before in the pipeline before training the target model. So some researchers reporting about 5% to 10% increasing of accuracy in classification and segmentation tasks. More interesting model is called mouse gun. This is another neural-based augmentation from medical image analysis. In this case, researchers uses image-to-image translation model to reconstruct the modalities. In this case, they have five modalities, and same as in one of the previous cases, they used the encoder as pre-trained network to target model for segmentation. The summary, this mouse gun network consists from two models. First, it's modality translation, and the second is segmentation. Another neural-based segmentation example is SimGAN, where where researchers report about that improvement. SimGAN, it's a one-shot model where the model using SimGAN architecture that training from a single image. So in this case, they get improvement only for very small data sets, like
Erkin, I'm really sorry, we are running out of time, so I should ask you just to go to the conclusion because no time is left.
Okay, two slides. Also, some research used mask to real image translation to generate the real images from the slide also deal with unbalanced class representation. in training data by manipulation with masks. For example, they can add more tree or cars and mask to generate from image from it, and such pipeline to generate. Firstly, we will generate segmentation mask, then then real image from this segmentation mask, and then using and image to image translate to get a segmentation mask. And some examples from fusion models. And conclusion. So the problem of lack of data exists and is solved in various areas by methods. And at the moment, the lack of data seriously affects the performance of segmentation form, Froth. There are also areas where it's necessary to back up a large number of similar objects in image. So finding the solution that can be applied to all these fields, not only to bubble segmentation, becomes the main task. So that's all.
And thank you.